All right, welcome to Proportions. Get your pencil paper calculator and let's go. Last time we talked about ratios, that ratios were a comparison between two different values, and the goal is to spot the relationship between them. So the individual values themselves are not exactly as important as the relationship between those values. So we're focusing on the ratio, the comparison between those values, not necessarily the individual values themselves. So let's now talk about proportions because that's the next step. Proportions would be two ratios that are equal to each other. And since ratio means the relationship, you know that what you're saying is that the two values have the same relationship to each other. So let's take a look at the first one now. One of the things that's true about proportions, if they're true, and I'm kind of asking that here, if they're true, the cross products have to be equal. What does that mean? That means if I take the numerator on the one side and I multiply it diagonally to the denominator on the other side, I get something. What's 12 times 63? That's 756. But now if I take the denominator over here and I multiply across the proportion, 42 times 18, oh look, I also get 756. So when the cross products are equal, then this is a true statement. It is true that 12/42 has the same relationship as 18/63. But instead of doing that, you might just even just convert them to decimals. If I did 12 divided by 42 and just get a decimal on the left, that's 0.28571 dot dot dot. It goes on. And then I'm going to get 18 divided by 63 and then compare that. Oh, look, I get 0.28571 dot dot dot. It's the same thing. Okay, so this one actually would be a proportion. That would be true. Well, what do you think about this one? You're going to say no. You're probably right because I'm giving you one that isn't. But let's just play the game anyway. Let's do the cross product. See if the cross products are equal. What's 19 times 19? That's going to be 361. And then what if I do 9 times 29? That's going to be 261. Are they the same thing? No, this is not true. It's false. Now, you can also put them into decimals. What if I did 19 divided by 9? I'm getting 2.1111 repeating on the left-hand side. And then 29 divided by 19, I'm getting, oh my gooseness, 1.526. So certainly not. This is no. That's not a proportion. Those two fractions are not equal to each other. Okay. Now, so here we go. If the cross products are equal, or you can just convert each side to a decimal. So are these proportions? Let's take a look. 27 tickets for 5 prizes and 51 tickets for 9 prizes. You ever play skee ball or something like that at the arcade and you get the tickets, or like you're at the fair and you're playing some kind of game and you get so many tickets and then you can go cash them in for a prize or something like this? Well, like, are these two ratios, are these two values for how many tickets compared to prizes, are they the same? Maybe one guy's got 27 tickets for 5 prizes and then some other guy, like on another stand's, got 51 tickets for 9 prizes. Like, well, where do I get more prizes for my tickets? Or something like that. So let's just try it. We could do 27 tickets for 5 prizes. And is that equal to, I don't know, I'm asking, 51 tickets for 9 prizes? And you could set the cross products equal. Maybe what I want to do here right here is I just want to convert them to a decimal so we can see what we've got going on. So 27 divided by 5, that's 5.4. 5.4 tickets for 1 prize. Now that's called a unit rate, right? We talked about that in the last video. How many for 1 is a unit rate? So 5.4 tickets. What about 51 now divided by 9? That's going to be, that's going to be 5.7 tickets if you do the rounding for 1 prize. So the prizes over here are more expensive. Now, if there are better prizes, maybe that's worth it anyway. But you understand the idea, right? These are not proportions. Are these proportions? That was the question. No. They don't have the same relationship between tickets and prizes. All right, so now you're going to go buy that 50-pound bag of meatballs at Sam's Club. Swedish meatballs, by the way. So you can buy a 13-pound bag, or $13 for a 2-pound bag, or $325 for a 50-pound bag. I'm not kidding. Next time you go to Sam's Club or Costco, look and see if they sell like enormous bags of meatballs, like dog food size bags. Let's try it. $13 for 2 pounds. And is that the same thing? I don't know. I'm asking $325 for 50 pounds. All right, so 13 divided by 2 equals 6.5. $6.5, $6.50 for 1 pound. Well, what's 325 now divided by 50? Oh my goodness. $6.50 for 1 pound. So yes, these are proportions. So why would you buy the 50-pound bag of meatballs instead of just buying a bunch of little 2-pound? But like if it was me and I'm just buying for myself, like I probably would buy the 2-pound bag of meatballs because I can't eat probably 50 pounds of meatballs before they go bad. So anyway, this is something to keep in mind. All right, now most of the time what you're going to see proportions with is not figuring out if they are proportions, although that's important. What you're going to do is you're going to solve them. And so you'll notice we got 2 fractions set equal. We're going to set the cross products equal to each other. That's the technique. And then divide. We're going to divide by the variable coefficient. I'll show you that. I'm doing a little bit of intro to algebra here, so this may be new to you. All right, so I got an equation here. I'm told, they're not asking me, I'm told z over 3, and z is just some number that we don't know. So the z is a temporary symbol, a variable, for the number that we don't know. But I want it to be equal to 8 compared to 15. So what I'm going to do is I'm going to take that property of proportions, that the cross products are equal, and I'm going to make an equation. That means z times 15, or 15 times z, I'm using parentheses here, has to be equal to 3 times 8. And I'm not even going to multiply it out. That's setting the cross products equal. That's me doing this step right here. This is like step 1. Okay, set the cross products equal. Now, I need to do a little bit of algebra, which basically says, how do I undo multiply by 15? Because I want to get z all by itself on the left-hand side. So right now it's 15 times z. How do I reverse that? How do I undo multiply by 15? Well, if we divide both sides of the equation by 15, divide by 15 on the left, divide by 15 on the right, the 15 divided by 15 drops out, and I just get z here. And now I can do my math. Most of you are probably going to reach for the calculator, so I'll do that one first, although that's not the best one. 3 times 8 divided by 15, I get 1.6. Woohoo! Okay, but sometimes you actually have to give your answer as a fraction, and so that's why I didn't multiply the 3 by the 8 to begin with here, because now when I've got 3 times 8 then divided by 15, I can reduce that fraction. The 3 and the 15 can be reduced. 3 divided by 3 would be 1. 15 divided by 3 would be 5. And so now, hope you got your pencil, paper, calculator. Now what do I have left on top? It's 1 times 8, which is 8, divided by just the 5 on the bottom, 8/5. Those are both equivalent answers. Yeah, let's do that one. Okay. Now, what I want you to do is I want you to pause the video, and I want you to try number 2 on your own with paper and pencil. Copy it down. Use lines for your fractions and stuff like that. And I want you to try that technique. Look, here, I'll even zoom back out so you can see the whole question. So you can see my one that I did up there. Okay. Stop the tape. Stop the video. It's not on tape anymore. Stop the video. And see if you can solve that. Go. Okay, if you did it, which I don't know, it's between you and heaven, right, if you actually did that or not. If you did that, what you're supposed to do is you're supposed to multiply The cross product. So find your variable and multiply it by the number diagonal. So it's going to be 14 times x. And it's only if there's an equal sign in the middle of the fractions. If it's two fractions added to each other, you don't do this. That's adding fractions. If it's two fractions multiplied by each other, you do something else. That's multiplication. This is only when you've got two fractions that are equal to each other. So you got to pay attention to, the symbol right there. Hey, only when they're equal to each other. Okay, so 14 times x must be equal to 1.6 times 21. And so then if I divide both sides by x, divide both sides by 14, I get x is equal to 1.6 times 21 divided by 14. And so now reach for your calculator. Why, Mr. Marsh? Because you've already been given decimals. Do you see decimals in the original question? Yeah, you're given information. Yeah, that means you're free to use decimals. So what do you get? I get x is equal to 2.4. Okay, that's good. Now, I want to show you just a little tip. If you can handle the algebra, that's good. It's good for you to be doing this mathematical thinking by writing. However, if you'll notice here, take a look at my little pointer here. Let me erase some of this stuff. Do my little pointer right here. The answer is 1.6 times 21, then divided by 14. Two things multiplied, and then divided by one thing. Look here. If you take the two numbers that you know that are diagonal from each other, not the variable, the other two, you're going to multiply these two numbers right here, and then you're going to divide by the number that's diagonal from x. The number that's diagonal from x always goes on the bottom. You multiply the other two that are diagonal, like catty corner from each other, and then divide by the one that's diagonal from x. That'll give you your answer. Okay? Now, number 3. Try it. Stop the video. Go for it. Seriously this time. Do it. Okay, we're back. Big numbers. How about y times 48? So 48y equals 16 times 100. And then if I divide both sides by 48, I get y is equal to 16 times 100 divided by 48. And if you reach for your calculator now, 16 times 100 divided by 48, what you get? Oh no, you get a repeating decimal. If you said 33.333333333333 and then never stop saying the 3, you would be correct. So when you get a repeating decimal like this is not the best way to do it. No. The best way to do it is to cancel. I don't want a decimal approximate answer. I want the exact answer. 16 and 48. What can those both be reduced by? Oh, does 16 go into 48? Hang on. 48 divided by 16? Is that a whole number? Oh, it is. Check this out. This reduces down to 1. This reduces down to 3. So what do I have left for my final answer? There we go. 100 thirds. That makes sense. 100 thirds. Not really 33.3. Not 33.33. Not 33.3333. Although if you did ... that would be okay. You might say 33.3 repeating, and but that's awkward. 100 thirds is the best answer there for that one. Don't turn it into a mixed number. It's got to be a ratio. All right, number 4. Lots of decimals galore. Oh, that was rhyming. Okay, try number 4. Stop the video. Go. Okay, we're back. So here we go. 0.25 times A, especially if you're from Canada, eh? And then we're going to have 0.12 times 50. And then so A must equal 0.12 times 50 divided by 0.25. So now let me reach for my machine, because certainly decimals are allowed now. 0.12 times 50 divided by 0.25 equals, oh look at that, 24. There we go. So proportions, two ratios that are equal to each other. The way that you solve proportions is you set the cross products equal to each other, and then you divide by the coefficient that's on the variable term. Or you're going to multiply the two numbers that you know that are diagonal from each other, and then divide by the number that's diagonal from your variable. Hope you learned something. Have a nice day. Bye-bye.